All right, we're looking at page 5 of the review packet. These top questions here, it says, hey, look at the reaction from number 1 and 2 on the previous page. So to answer these questions, I'm simply just going to look at these. Okay, it's asking about 1 and 2 here. Okay, so we'll answer it just looking directly at those questions. So number 1, I want to know what type of reaction I have. This is a single replacement reaction. Okay. The reason I know that is you have a single element here and you have a compound here, and only one of those things is replacing. Aluminum and hydrogen are swapping spots, so it's a single replacement reaction. Here you have a double replacement reaction. Okay, you have a positive here and a negative here. You have a positive here and a negative here, and the positive swapping with the negative. Okay, when you do that twice, there's your double replacement. Okay. When I move down to here for 2A, I also have a double replacement reaction. Okay, same deal. You have a positive going with the negative. Okay, so you have both of them switching. For B, you have a synthesis reaction. Okay, synthesis reaction, you have two single elements. Those elements are combining to make one compound. We've discussed this already. You have a combustion reaction here. The reason you know you have a combustion, you have a carbon-based compound and oxygen. Every time you're going to get CO2 and H2O as that product. And that last one, you have a single replacement reaction. Again, that positive barium is coming in and replacing the positive iron, and you're going to get barium chloride as opposed to iron chloride. Okay, so that answers those top questions. Again, if you need to see them, we have a single replacement, we have a double replacement, synthesis, combustion, and single replacement. Okay? Write a balanced equation for the reactions below. Fluorine reacts with sodium chloride. So I have fluorine plus sodium chloride. Now I have to double check. Fluorine. Fluorine is a Hunkelbrief. It's a diatomic molecule. I got to make sure I put F2, excuse me, plus NaCl. That fluorine is a -1. That's a positive 1, -1. Okay, so that negative is going to want to swipe in and replace that positive. So it's going to become, it's going to replace that other negative. So it's going to become NaF plus 1, -1. So you don't have to do anything. They cancel each other out. Plus Cl. Chlorine is another diatomic, so that is Cl2. Then I have to check to see that it's balanced. I have two F's over here. I only have one over here, so I put a 2. That changed my Na. That changed my Na. That also changed my Cl, so I'm all good. Potassium iodide, Ki, plus 1, -1, I'm all set. Plus magnesium sulfide, Mg, SO4, plus 2, -2, I'm all set there. That's going to be a double replacement reaction. Okay, this is a single replacement reaction, just for reference. This is going to be a double replacement reaction. Positive is going to replace there. That's going to replace there. So then I'm going to get K SO4 plus 1, -2. So that 2 is going to come down. Okay, you don't have to write those. I'm just putting it there for reference. And then plus MgI. And this is a plus 2 -1. So it's going to get that. I then have to balance them. I have 2 Ks over here. If I put 2 here, change my iodide to 2, change my iodide to 2, and everything else is balanced. So I'm all set. Okay? All right, moving on to molar mass calculations. Okay, what is the molar mass of zinc nitrate? To do this problem, I'm going to reference my periodic table. Okay, I'm looking at the molar mass number, so I have zinc, I have nitrogen, and I have oxygen. Okay, so those are the numbers I'm looking at, 65.39, 14, and 16. I'm just going to lay them all on a table. I'm going to say zinc, I have nitrogen, I have oxygen. I have 1 zinc, I have 2 nitrogens, and I have 6 total oxygens. Then I multiply them by their molar mass, 65.39, 14, 16. I total that whole thing up, I get 189.39 grams per mole. Okay? All right, formula for bromine gas. Simple question, but could trip you up a little bit. Bromine gas, that's bromine. The problem is bromine gas, bromine is a diatomic molecule, so it's going to be Br2. So a lot of people would probably put the answer of 79.9 as the answer. That is incorrect. You have to multiply it by 2 because it's diatomic, so you get 159.8 grams per mole. Okay? All right, mole conversions. Let's do some stoichiometry. I know we're excited. How many atoms and 2.3 moles of hydrogen gas? I start with what I know. I know I have 2.13 moles of hydrogen gas. I put a placeholder. I want to cancel moles, and I'm going to go to atoms. I can go directly from moles to atoms. Okay, 1 mole contains 6 times 10 to the 23rd atoms. And then what I'm going to do is in my trusty calculator. Oh, sorry. Oh boy. I am simply going to do 2.13 times 6 EE23. That's going to get me 1.278 E24. What that means is 1.278 times 10 to the 24th atoms of hydrogen gas, atoms of H2. Okay. How many grams are in that many molecules? Well, let's start with what I know. 7 times 10 to the 23rd molecules of H2O. Placeholder. Cancel molecules of H2O. So I'm going to cancel molecules of H2O. I'm going to go to moles of H2O, 1 mole, and cancel my molecules of 6 times 10 to the 23rd. And then I'm going to cancel moles of H2O, and I'm going to go to grams of H2O. 1, and on my mole map or on the wall, whatever you look at, I can look at that equality, grams to moles. It's going to tell me X grams, and I have to look off my periodic table. Looking off my periodic table, I have to find the molar mass of water, 16 and 1. So this is going to be a total of 18 because I have 2 waters, or 2 hydrogens. Plug that in my calculator. If I was to plug this one in just to show you what I would do parentheses 4.67 EE23 times 1 times 18 close parentheses divided by open parentheses. So it's everything on the product at the top divided by the product at the bottom. 6 EE23 times 1. I understand you don't have to multiply by 1. I'm just saying in case it turns into a different number at some point. 14.01. 14.01, and I'm solving for grams of H2O. Okay, so there's some quick conversion questions for you. All right, here's some more conversion questions. Head down to the bottom. How many moles of HCl are needed to produce that many moles of aluminum chloride? This is that center reaction on the mole map. It's moles, balance equation, moles to moles. So I start with what I know is always 7.6 moles of AlCl3. I'm going to cancel moles of AlCl3 because I don't want them. I do want moles of HCl. And I have 6 moles of HCl, and I have 2 moles of aluminum chloride. And then all I'm doing is saying 0.76 times 6 divided by 2, so I get 2.28 moles of HCl. And last but not least, how many grams of hydrogen are produced from 34.5 grams of aluminum? Okay, start with what I know. 0.5 grams of aluminum. Placeholder, cancel. I don't want grams of aluminum. I got to get to hydrogen, so I've got to cross over. I at least have to get to the moles of aluminum. So I'm going to go to moles of aluminum. And then I know I'm going to have to get rid of moles of aluminum. I'm going to go to moles of hydrogen, and I know I'm going to have to get rid of moles of hydrogen because I need grams of hydrogen. Working my way back, it's always 1 mole. It's going to be 2 grams because hydrogen's molar mass is 1, and it's H2, so I got 2 of them. Here's my mole to mole ratio, so I'm looking back at the top. I've got 3 moles of H2, and I've got 2 moles of aluminum. and then 1 mole here, and my molar mass of aluminum is 29.9. I plug all this into my calculator, and I'm going to get 3.46 grams of H2. Okay, so that's it for that page.